Okay, so this is the first lecture of 2 for today. Sorry I didn't get it up online to begin with onto YouTube, but we'll go from here. First off, this is the homework for next Wednesday. By the way, some of y'all are not turning in the homework, and you have to turn in the homework in order to pass the class. I think I got maybe 10 or 15 homeworks out of 37. So if you're not turning in the homework, you best be getting with it, because you're not going to pass if you don't have 70% on the homework. And granted, everybody's doing pretty well, but you got to turn in the homework. So what I want you to do is find VO across the 6 ohm resistor for this homework. This is the sample 5 test problem. I want you to find VO of T for T greater than 0. All right, so one of the things I got in an email is, could I work and explain how I got the solution to problem 5 on the solution on the sample test. So with that in mind, let's go and do that. This lecture will be this, and we'll see how it goes. All right, so given the problem, they wanted to find IO of T for T greater than 0. And you were given that IL0 equal 2 amps, and you were given that VC0 was 5 volts. So probably step 1 and step 2 you're basically given. You know, if you read step 1, it says find the open circuit voltage across the capacitor and find the short circuit current through the inductors. Notice I have 2 inductors here. I will ultimately put those 2 together. But since they're all in series, they're all in a series circuit here, that means 2 amps is going through this series circuit. And then it divides up and splits and then comes back and goes into a series circuit again. So basically, like I said, step 1 and step 2 are given. IL0 minus equals IL0 plus equals IL0, which is 2 amps. And VC0 minus equals VC0 plus equals VC0, which is 5 volts. So if I keep going down to step 2 and reading through the step by step, it says, well, I need to find IC0 plus, and I also need to find VL0 plus. So I'm going to go through, and it's pretty easy to see that from this circuit that this current goes through this series network right here, and it goes through the capacitor. So IC0 plus then is going to be 2 amps. Well, then I keep on going, and I'm going to clean up the circuit. And so what I'm going to do, I'm going to get LEQ, I'm going to get CEQ in a decimal format. I'm also going to clean up my resistor, because what I need to do next is find the voltage across the inductors. Okay, so I go in and I find LEQ, which is 1/8 of a Henry, plus 1/8 of a Henry, which is 0.25 Henries. So 1/4 of a Henry. They just add up because they're in series. Also, there's only one capacitor, so CEQ is pretty easy. 1/25 farads gives me 0.24 farads. And then the resistor network reduces down to 4 ohms. I've got an 8 and a 4 in series, and those 2 are in parallel with the 6. So 8 plus 4 in parallel with 6 gives me 4 ohms. All right. So now I also need to go in and find in step 2 what IO0 plus is. So I'm going to find IO0 plus based on that resistor network I just drew. So using current divider, I know that IL0 plus is coming into this node right here, and I can use current divider to find the current going this way in the 6 ohm resistor, right? So I have to hit the 2 with a minus sign, And so using current divider, IO0 plus equals minus 2 amps times the one I don't want, which is 8 plus 4, divided by the sum of all the resistors, which is 8 plus 4 plus 6. And I get IO0 plus is minus 1.33 amps. So now I've got IO0 plus. I still need to go in and find what's going on with VL0 plus, the voltage across the inductor, the combination of the two. And remember, I've got 2 amps flowing in this thing, and notice that I put my 4 ohm resistor here. So Ohm's law states that I have to find the voltage in the direction of the current. Current has to enter plus sign of the voltage drop across a passive element, RLC. So I've given 5 volts. I can find the voltage across the 1 ohm resistor. It's just going to be 2 amps times 1 ohm. I can go around and find the voltage across the 4 ohm resistor, which is just 2 amps times 4 ohms. And then I can go in and I can do a KVL equation around this and figure out what VL0 plus is. So I start down here in the bottom left-hand corner like I always do. And I come up and this is going to be plus 8 volts. Plus VL0 plus the 5 volt drop across the capacitor, plus the voltage drop across the 1 ohm resistor, which is 2 volts. And so here's my KVL equation right here. It says that 0 equals the summation of those voltages. So 8 volts plus VL0 plus 5 volts plus 2 volts. And I get VL0 plus equals minus 15 volts. So now I have found everything I need to find in step 1 and step 2. So now I'm ready to go to step 3 in our step-by-step method. And so the first thing I do is go in and I find alpha, which this is a series LC network. So it's going to be RTH divided by 2 times LEQ. Well, RTH is going to be 4 ohms plus the 1 ohm, because they're in series. 4 ohms plus 1 ohm gives me 5 ohms divided by 2 times 0.25 henries. And this gives me a value of 10. Alpha squared then is 100. And omega naught squared is 1 divided by LEQ times CEQ, which gives me a value of 100. So alpha squared equals omega naught squared. So we know now that this is a critically damped circuit, and we're ready to go to step 4. Step 4 is find IO at infinity. Well, if I go back to the network, the original network for the problem, I notice that there are no sources of any type in this problem. So I know then that the resistors in the circuit are going to drain the storage devices of all their energy, and so there won't be any current flowing in that circuit at time equal to infinity, whatever that might be, 5 time constants later, quote unquote. So IO at infinity is 0 because there are no sources in that circuit. So now I'm ready to go to step 5. Okay? So if I go to step 5, it basically says I have to solve 2 equations and 2 unknowns. Granted, it's really, I solved 1 equation with 1 unknown, and then I solved the second equation with 1 unknown. So I know what IO0 plus was. It was minus 1.33. I know what IO at infinity is. It was 0 plus D2. So D2 equals minus 1.33 amps. Okay? So now then, I need to solve the Hard equation. Equation 2, which I have to go in and somehow find DIO0 plus DT. Because the second equation is DIO0 plus DT equals minus alpha times D2 plus D1. So I have to solve for D1. I have minus alpha, I have D2, and I've got to find this value. So what is DIO0 plus DT? Well, I go back to the original circuit again, and I see that this is a series network. And so I can find DIL0 plus DT using Ohm's law for the inductor. And I know that that DIL0 plus DT is going to divide just like the 2 amp current did. It's going to divide and go, part of it's going to go up this way and the other part's going to go up that way. Current divider still has to obey these rules that we have set down. So I need to basically go in and figure out what's going on with this circuit right here. I need to find DIL0 plus DT, because I know if I can find DIL0 plus DT, I can do current divider and find this DIO0 plus DT. So there's my problem. How do I do that? Well, I'm going to go find DIL0 plus DT first. Well, here we go. DIL0 plus DT using Ohm's law equals VL0 plus divided by L. I found a value for VL0 plus, which was minus 15 volts, divided by 0.25 henries, which was the total inductance in the circuit, and I get a value of minus 60 amps per amp, okay? Basically, it's unitless, but I'm going to call it amps per amp so I know that it's amps, okay? It's an amp type value. All right, so I've got DIL0 plus DT. I need to do the current divider now across these resistors to figure out what is DIO0 plus DT. So I come over here. This is minus 60. I always pick the ones I don't want over the ones I want, okay, and opposite. So here we go. I get DIO0 plus DT equals minus, because I'm going in the opposite direction, I'm going down this way, and my current's going in this way. So this is going to be minus the minus 60 amps per amp times the one I don't want, which is 4 ohms over 8 ohms, divided by 4 ohms plus 8 ohms plus 6 ohms. And I get plus 40 amps per amp is DIO0 plus DT. So sticking that into my equation, 40 amps per amp equals minus alpha times D2 plus D1. Minus alpha is minus 10. D2 is minus 1.33. And that total gives me a value of, when I throw 13.33 over to the other side, that's minus 13.33. So D1 equals 26.67 amps per amp. Okay. So finally, the solution then is going to be IO at T equals IO at infinity plus D1 times T times e to the minus alpha T plus D2 e to the minus alpha T. And when I stick those values in, I have 0 plus 26.67 times T times e to the minus 10T alpha minus 1.33 e to the minus 10T amps for T greater than or equal to 0. So that's the end of this video, and I will be back on here in just a minute or two, and we'll do the AC intro